everyone, Down at Dawn again here with the next update on my 1/2 scale War Corsair project. Again, not an RC model. I'm going to go do a midweek update here real quick to let you guys know what's been going on. Last video you saw I was having trouble with the tachometer, so we're going to address that tonight. But one of the main reasons I wanted to make this video was because of this. As you can see, this is the aircraft registration. That just came in the mail Monday, so that's half of the battle with the FAA right now. So that's done. It is now a legal airplane, and that's the tail number 18086. Serial number 489. So War Aircraft Replica Corsair, registered to me and built by me. So that's the main thing I wanted to point out. And the second thing was the issue with the tachometer. Alright, I was doing a bunch of research, and what I needed to do is get the tachometer to read over 4,000 RPM. It would stop responding to 4,000. I wasn't able to pitch the prop. As you can see, I got the prop off right now, and I'll tell you why in a sec. But anyway, what I needed to do was, I was thinking that the signal coming out of the PCM, the computer for this engine, is an electronic signal for a modern day tachometer. Well, this tachometer is meant to be used in like a Rotax 2-cycle aircraft engine, and it's the same thing that's found in Ski-Doo snowmobiles basically, but aircraft versions. And it uses a CDI type ignition system where it picks the signal up right off of the coil. So, but in this configuration, what I wanted to do was tap into the signal that comes out of the computer that triggers the coils, which is, there's two triggers here. You got trigger 1, trigger 2, in the middle is 12 volt power. You can see I got a little red wire on there where I tapped into this one trigger. This trigger pulses the coil. There's two separate coils here. One trigger fires 2 coils at a time, which fires one plug on each side. One's on compression, one's on exhaust. And then the other trigger fires the other coil and does the same. So, but turns out this has an amplifier in it. The signals coming from the computer come in here and then goes through some circuitry, some transistors and such, and then it comes out and triggers this. So what I want to do is try and see if I could trigger off of one of these. So I pulled one of these out, tapped into it with a wire, run it over the airplane outside into the plane and hooked it up to the tack and fired it up the engine. Wouldn't register a thing. So the signal coming into that's even weaker than the signal coming out of the PC for the tack. So my next option was to take it right off the coil like it's meant to be hooked up. Hooked it up to here, did it again, started up, same. This time it worked, but again it only went to 4,000 RPM and petered out. So back to the drawing board. So I went through, I was looking up all kinds of tack adapters, and there's so many different types out there for different applications, but nothing that really seemed to want to work for this. But in my research, and what I finally figured out was these computers on all modern day cars uses what's called a reference voltage. So everything in the computer system goes off of a reference voltage, which is mostly 5 volts on pretty much everything out there. And the 5 volt signal is, 5 volts gets powered to your throttle position sensor, and there's other sensors that use a 5 volt input, and as things vary, it varies from 0 to 5 volts output. Mass air is 12 volts, but there's certain sensors on the motor that all reference a 5 volt signal, emissions, components, and such. So the problem is the computer outputs a 5 volt, I'm pointing here because the computer's right here. It outputs a 5 volt signal, and the tack is designed to work on a 12 volt signal, which the coils are on the engine that it's meant for, is a 12 volt signal. But it's not just a plain 12 volt signal. It's a spiking voltage, because when you energize an electrical coil and when you shut that coil, you put power to it and release the power, that causes a back spike in voltage. It's like a flyback. It's called a flyback voltage. It's a high voltage spike. And that's what the tachometer is looking for. It's looking for that high voltage spike, which is generally higher than 12 volts. It could be hundreds of volts. But anyway, it's looking for that high voltage spike and then a ground, and then a high voltage spike and a ground. That's what makes the tack work. So, find out that people are making their own little gadgets here from just a simple relay. you got a regular, I call them a Bosch 30 amp relay. I use them all through the plane. There's two of them right there for the landing gear. There's two of them behind here for the flap motor. And this is a spare one I had. This is just an actual Ford that plugs into your fuse panel in the engine compartment for who knows what, fuel pumps and such. So you crack this thing open, and basically all you're looking to use is a little coil in here. A little coil that energizes and pulls the points down and makes the contacts. So you can tear all the points out of it. All you're looking for is just these two coil wires, the input and output of the coil. The rest of the stuff, you cut it all loose and tear all the guts out. So that's what I did here. And then you take and put in one little transistor and 1 k ohm resistor. And I got a quick drawing here if you want to see what I did. Essentially, you have a light here. This is representing the relay. You have a pin 86 and 85, and this is the coil inside. These are the only two terminals that you're looking to use. The rest of these other two pins, and there's usually a fifth one here in the middle for a normally closed. So when the points are closed, when you energize it, one point's open, one's closed, and when you energize it, it reverses. The other one closes and the other one opens. So, and then you got your pin 87 and pin 30, and this is where your power would come in to pin 30. Your 12 volts would come in there, and then when the points close, it sends power out 87. And when these are open, this point for the middle one is closed. So you got one closed and one open, and when you energize it, they reverse. So you don't need the center pin. You can get these actually with just 4 pins with just a normal switch, one switch, normally open switch. When it energizes, it closes the switch. So what you can see here is this is pin 87. You put a 1000 ohm resistor in there, and you bring it over and you hook it onto pin number 2 of a transistor. I ended up using a 2N22, 222A, I believe is all it was. It's transistors, 3 pins, pin 1, 2, 3. And it hooks to what is known as the base. You got base, collector, and emitter. Collector, yeah, this is collector, this is the emitter. Emitter goes to ground. The arrow indicates the flow of power. So then you bring 12 volts, you put 12 volts to this pin, goes through the coil, comes to this pin, goes into the collector, and then when this signal triggers, hits this thing, it closes this, and the negative ground goes through here to pin 30, which is to the ground of the chassis. That's all it is. One little transistor, one little 1K resistor. And what that does is this coil is the secret here. When this thing energizes, when you close the trigger here and it makes this ground through the switch, this thing energizes, and then when this thing opens, the switch opens back up, you get a reverse voltage spike back through this coil and causes a high voltage spike. And that's the spike that's needed for this thing to trigger properly. So I made this up, and that's the one I just showed you. The problem, like I said before, was this thing would not rev over 2,000 RPM. Right now I got the tach just kind of sitting here. Let me go ahead and show you real quick that it works. You got the power switch, fuel pump, one of 2 fuel pumps, and the alternator switch, and then the key. So here's the fuel pump. Let me start it real quick. There's the tach. I'm going to see if I can get this. I'm not sure how I'm going to do this. I'll show you, but see if I can't hold her. Take her and rev it up. I can get this steady. All right, here we go. See what happens. Oh, I'm sorry. That's hooked up normally. You see, it wouldn't go over 4,000 RPM. All right, let me do this real quick. Sorry, I wanted to show it this way. I'm going to go ahead and disconnect the signal wire here. I'm going to hook it back up to my circuit. We got a red, where are we at? 2 triggers here. Bear with me, folks. Red and yellow. Let's see, the yellow is the ground, that's good. Okay, so the red's the input. The red's going to hook up to this wire. And then the ground hooks back up to here, the output. sorry, I'm knocking this thing around. So, but anyway, let's try it again. Hopefully I got this right. Alright, still working. Still tag hole here. There it is, it's fixed. So that was the problem. So now, I won't probably get to this till the weekend, but basically I'm hooked to power, ground over there, power over here, feeds the power and ground of the relay, and then the trigger from the computer comes out here. It's kind of fogging up in here, I think. This is the trigger from the computer going into my little relay, and then out of the relay into the Tach signal down here. So it works like a charm, and it didn't cost me anything. Alright, now the last thing, the third thing, I keep mentioning that I have to give this thing some ground handling. You know, I'll probably put several hours of just ground handling on this thing before it flies. The reason for that is basically to test this aircraft out. Make sure there isn't going to be any problems in the air, so you want to test it on the ground first. And basically everything from the firewall forward on this airplane is untested. None of it's tested. I don't know if the cooling system's going to work or whatever. Well, remember last video I had the exhaust I pulled off to put those heat shields in, and I put the muffler net all back on. Everything was fine. Then I went out and ran it up with the prop on there to try and find this, set the pitch on the prop, and I couldn't get it to rev over 4 grand on the Tach. So, and in doing so, I had to come out here and pull the cowling back off so I could tap into these wires. And if this would have worked, I could have come in back here to the computer and used that, but it didn't work. So I had to pull the cowling to do that. And when I did that, I noticed the top of my muffler. I was like, where's my O2 sensor? It fell out. So I fished back here and pulled it out. And here it didn't fall out, it broke out. Where the nut was welded onto the steel, the stainless steel, just from that little bit of running of, you know, maybe an hour of starting and running this thing, that thing literally broke off where it was welded and fell off. So I had a big hole on top of the muffler just blowing hot air up into the motor. So I had to pull that all off. I went in, and you probably can't see it, but I welded a patch, like a 2 1/4 inch stainless patch on top of over the muffler hole, drilled it out, and then re-welded the nut back on there and put it back on. And then in doing so, taking it off, the tape that I wrapped these with, that was around the muffler, it literally just started falling apart as I was taking it off. It was tearing and falling right apart. So what I'm going to do is I'm going to buy some more of that ceramic blanket, and I'm going to wrap the muffler in that ceramic foil blanket. But that's the reason why you have to test and test and test before you ever take off with this thing. You got to test. I mean, this is, like I said, it's an untested power plant. All this stuff is going to be fine. The muffler, I may have to build a new muffler. It may not hold up. That was the only place it broke. The rest of it, I mean, it's a fairly thick gauge stainless. You don't want to go too thick because it'd be too heavy. We're talking that's 35 thousand stainless. This stuff here is like a 1/16 inch. It'll probably last forever. But there's no weight on that sensor. The sensor's just sitting right on the top, but yet it broke around the weld. So I welded a thicker patch on there to give it more surface area and put it back together. But that's the reason for testing. When this thing's out on the runway bouncing up and down on that sod grass field, if anything's going to happen, it's going to happen on the ground. So you're going to run it for an hour, pull the cowling, check the airplane out, and just keep going. And as everything looks fine, then prior to an actual test, then you'll be taking the cowling off, looking the whole plane over, make sure everything looks good before you do a test. And then the test is literally going to be just pattern flying. It's really pretty much taking off and flying around. The best thing to do is get it up to some altitude and find out where it stalls so you know what your landing speed is going to be. But you can always come in hot. But that's the reason for the excess time I'm talking about ground handling. Everything's untested on this aircraft. The flaps are untested. They've never been used. No war aircraft has ever had flaps, and no war aircraft's ever had this thing. So, all right, I just wanted to make this quick video to get you guys up to power on this thing. So this weekend I'll get that Tach all squared away, get it wired in properly back in the plane. check everything back over again on this. Put the prop on it. The only reason I took the prop off was so I could start it in the garage. I left the prop off so I could start it without dragging this outside and tying it down. Because that thing has a flywheel on it, so it's not hurting the motor to run it. It still has a flywheel. So I'm able to rev it. And you can hear when I first revved it there, it hit the rev limiter. So that's over 6,200. But it wouldn't go over 4,000 on the Tach. So now it goes up to 6,000 just fine. So I'll put the prop back on it, get the cowling closed up, give her a good check over again, then I'll take it out, tie it down, and run it up. But I already set the propeller to the correct pitch. I ended up at 10 degrees pitch. But I ended up using my voltmeter on frequencies to, I know I needed around, was it 180 hertz, and that's where I set the pitch of the prop, and it took, so putting the prop on and running it and checking it against the Tach, we'll see if we're in that 5,500. All right, folks, I'm going to go ahead and cut her off here. I just wanted to get this in and let you guys know what was going on and just give you a little content. And then this weekend, after I get it all back together, hopefully it won't rain this weekend, I get the wings on it and get it the last weight and balance done, and then it should be pretty much ready to call the FAA up. Again, I still have these covers to do down here and some touch-ups here and there. Little things, but for the most part, it's a legal airplane now. Now I just got to make it legal to fly. All right, folks, again, as always, appreciate you taking time to watch these videos. Feel free to leave any comments, questions, concerns. Hit the like button, subscribe, you know the whole ordeal. And appreciate all of you returning viewers, and appreciate new ones coming in every day. So, all right, that's going to do it for this update, folks. Thanks again. This is going to do it for now, and I'll catch you in the weekend. So, Dino Don, this is out. Bye-bye.